Hi, everybody. I'd like to thank you for being on time. My name is Ryan Davies. I'm the VP of Sales here at Yotta Energy. I'm very excited. We haven't done one of these in a while. I'm excited to be back with you. And today it's focusing on what we do best, and that is our SolarLEAF rooftop battery. Joining me today is my colleague and great friend, Mr. Christopher Barrett, Director of Sales Engineering. Chris, how are you doing today?
I'm doing well. Thank you so much. Looking forward to the webinar today.
I'm looking forward to it too. Like I said, we haven't done one of these in a little while, and it's good to be back on the horse as it is. So you may know a little bit about us, but let me just give you a bit of a refresher. A little bit about Yotta Energy. Energy made simple. We're leading the transition to clean, renewable energy by making energy simple. We have a complete range of distributed solar technologies for the C&I market. That's a key distinction. We focus specifically on the C&I market. Yotta's technologies were made with the goal to convert commercial buildings into solar power plants. We were founded in, we're coming up, it's hard to believe, on our 6-year anniversary. And we are located in Austin in the great state of Texas. And we're rolling around just over 40 employees these days. We've got a number of different awards and recognitions. And if you want any more information on those, of course, those are available on our website. As we like to do during these events, we like to give away a prize bag at the end. One of the things we're most known for on the trade shows, and for those of you who have seen us, is we got some pretty good merch. We got a guy who's real good at designing our shirts and our hats and our other giveaways. So shout out to Thomas there. He does a fantastic job. Those things don't last long, but we'll make sure that one lucky attendee today gets a nice bag of Yotta merch. So hang around, and the marketing team will randomly select an attendee at the end of the webinar. Just before that, we'll do a Q&A session. So if you have questions, please type them into the chat, and we'll try to address as many of them as we possibly can by the end of the webinar. If we don't get to yours during the live session, rest assured, someone from the sales or engineering team will reach out to you directly, and we'll make sure we get all your questions answered in a timely manner. I think with that, I'm going to hand it off to my buddy, Chris. Chris, you ready to get started?
I am ready. Thank you so much. And thanks everyone for joining today. Thanks for taking time out of your day to learn more about Yotta Energy and the products and services that we offer. One of the slides I love to present first, just to get it out of the way, is how do you pronounce the name? This is a very common question we get at trade shows. We're out on the road. It's Yotta, not Yoda. Just a little funny thing here, but nonetheless, just gives you an idea how to say that. The next logical question is, what does Yotta mean? And Yotta is basically this SI prefix for 10 to the 24th power. Currently the largest decimal unit prefix in the metric system. And just to put it in perspective, just kind of gives you a little bit of an idea. We're all familiar with the kilo, the mega, the giga, the tera. We're all the way out at 10 to the 24th, 1 septillionth. Just a little education here for the webinar as well. All right, let's dig in. So as far as the agenda is concerned, we're going to run through all this right here. We're going to talk a little bit about introduction about the company, about our ecosystem, talk of course about the SolarLEAF, which is the mainstay today, Yotta Vision, basically our online monitoring portal, our Yotta DPI microinverter, which complements the SolarLEAF, talk about some case studies, talking about the clipping time of use, demand charge management, and demand response, all which happens within inside of the SolarLEAF battery. We'll talk about some kind of installation and design, proposals, projects, and partners. And then like Ryan said, wrap it up with some questions and answers at the end. Let's dig in. So let's first talk about the Yotta ecosystem. The Yotta ecosystem, as you see here on the screen, consists of very, very simple parts. We're looking at a solar module that plugs directly into what we call the SolarLEAF, or the energy storage battery, which then plugs into one of the 4 ports of the dual power or DPI microinverter. This particular microinverter is a 3-phase, phase monitored, phase balanced, comes in 2 different versions, 208 volts and 480 volts, all of which then plugs right into the sub panel and then out to the main supply. The other thing that we have on our list of goodies is a Yotta EV car chargers, which plays in this environment and communicates wirelessly to the gateway, which we don't have on the screen here, which we will talk about later in the presentation. With SolarLEAF, we call this a PV coupled system configuration. As you mentioned before, PV modules are at the top of the food chain here. Those PV modules feed each one of the SolarLEAFs. One question we do get quite often is, how many SolarLEAFs can I have, or how many do I need on a site? And that really comes down to your electrical configuration, your consumption or your needs for that particular site. We can talk to a regional sales manager in the future to figure out what you need for your particular site. But as we get deeper in the presentation, we'll learn more about what the requirements are. But as you can see from this picture, we've had a complement of SolarLEAFs plugged into the modules, but again, we don't here, giving the name of the inverter the DPI, or the dual power input, meaning that it can take power from a module directly, as seen here, or through the SolarLEAF. All of this comes down to basically a trunk line. We call it a trunk gauge, and it's 30 amp, 3-wire, 10 gauge trunk line. In this particular example here, we're showing those inverters coming down to a 30 amp, 3-pole single throw breaker in the sub panel, a single line out to the main, and then out to the utility. For those of you out there that want to see this a little bit more of a schematic, again here, we're showing the PV module going into the SolarLEAF going into a single port on that microinverter, again, times 4, because we have 4 ports on that microinverter, coming down to that trunk line, out to that junction box, into aggregation panel, and back out to the street. The combination and the SolarLEAF is an ideal combination, because what we're trying to do is basically have a low voltage system on the roof. The highest voltage you're going to have DC side is the module voltage coming off that module. Typically today we're looking at 48, 50 volts maximum, especially for these higher wattage modules. With the microinverter, we're also going to have higher production, because we're going to be able to mitigate any kind of shading from any kind of rooftop obstructions. We'll also have module by module visibility to what's on the roof. The other nice thing is rapid shutdown compliance. This meets all the NEC 690.12 compliance. And then troubleshooting in the future. As far as O&M is concerned, it couldn't be easier. You'll have information right at the finger, right at your hands with your app or on a computer. As far as the SolarLEAF is concerned, it's modular and scalable. As you can see right here, it takes one SolarLEAF, can take one module. That is my only limitation today. I need to have one solar panel or solar module to charge one SolarLEAF. But the nice thing is it's plug and play. It can be plugged out. The biggest concern I have, or constraint I have, is the number of solar modules. If you have 500 solar modules, you can have 500 SolarLEAF. You cannot have 501. Again, because I need one solar module to charge one SolarLEAF. This information is readily available online again. Actually shortens payback time, and this is where we're talking about the peak shaving, time of use, demand charge reductions. These are all the benefits of the SolarLEAF. This right here is a nice graphic, kind of shows a panel claw racking, so a flat roof design, commercial design. You can see the inverter being put down, put into the tray, and grounded to the railing. You can see the SolarLEAF flying in and actually sitting there as a ballast block replacement. Note that the SolarLEAF itself is 53 pounds, so it is equal to 2 ballast blocks. That gets put in, gets screwed in, and gets grounded. All the DC connections are made from the solar module to the SolarLEAF, out of the SolarLEAF into the DPI. And here's a non-video version of what we just saw right there. So my head's not spinning any longer. But this really shows you here. This gives you an idea as far as the microinverter in place, inside the racking, and grounded to that racking. The SolarLEAF also put in place, takes up to 2 ballast blocks. The input from the solar module would come here, the output into the single port of that microinverter. We believe this is actually a very simple and easy installation. It's actually able to grow very easily, and we believe it's the safest between the microinverter technology having that low voltage voltage on the roof with the SolarLEAF itself being on the roof, distributed throughout the roof instead of all together, safest and lowest system cost. Let's talk about some of the key specifications of the SolarLEAF. So as far as the PV input's concerned, we're saying we can have up to 750 watt modules today. So that right there will meet any requirement for most modern modules today on any kind of commercial roof. Module compatibility, 60, 72, 120, 144 for the split cells, and also bifacial as well. What I really care about is that voltage input and that current input, all of which is on our spec sheet on the next page here. Inverter compatibility, again, Yotta DPI microinverter. And again, just to mention again, 208 volt and 480 volt native 3-phase. Capacity, it's a 1 kilowatt hour battery today, 0.8 usable capacity, because we charge to full and then use to 20%. That number can be changed, but that's the way the system is designed. Lithium iron phosphate, one of the safest chemistries today in the industry, with a design life cycle of 6,000 cycles. We're looking at almost 15 years of being cycled day by day in a commercial environment. As I mentioned, 53 pounds, 2 ballast blocks. So the weight right there itself, instead of putting up concrete on the roof, now we're putting up some useful piece of equipment on the roof. One question we do get a lot, well, how much does this change the load calculations of the roof? No, absolutely not. It's a zero net gain. Basically, you're removing 2 ballast blocks, you're putting on a SolarLEAF. So basically zero is the pounds per square inch, pounds per square foot is 2.7 to 3. But as far as the replacement of the ballast block to this, zero net change. Mounting options, okay? This is typically used in a flat roof commercial environment, but we have plenty or many actually racking in a ground mount situation as well. As you can see on the SolarLEAF itself, you just see it barely here. These are mounting tabs that can be used to mount those onto the racking as well. Operating temperatures, you see over here, 20 to 65 C, that right there. And dimensionally, you can think of it as kind of a small suitcase. But the nice thing about it, it's a one-person lift, one-person carry. So it's easy to install, very easy. This right here is a specification sheet. I'll pause here for a few seconds and give you an idea. You can take a look. If you have your phone, you can scan that QR code. That will take you to the SolarLEAF specification. And you can download that to your phone or your computer and have all the specifications, everything you need. I'm going to have a few of these places during the presentation today that we can stop and pause. So make sure you have your cameras, or your camera or your phone readily available to scan. Okay, moving on. Let's talk about the thermal engineering, right? This right here, I like to call this our secret sauce. One of the things that we always talk about as a battery company is, people say to us, like, well, how can you put a SolarLEAF? How can you put batteries on the roof? It's a very, very harsh environment. And that's just it right there. We currently have 6 patents in it, and those 6 patents all are thermal management related. Okay, so the really important thing is we want to make sure that we create this envelope of air surrounding the batteries to basically just prolong the life of the batteries, keep them in that nice working condition. What we're trying to do is keep them between 20 degrees C and 40 degrees C. That's the operating optimization for the battery technology. And how do we do that? Big question, right? So number one, we use vacuum packed ceramic boards. These vacuum packed ceramic boards act as an insulator. So the vacuum itself is a very, very poor conductor of heat. So it won't let heat pass through one way or the other. Think of it like a thermos. Put coffee in the morning when you leave the house. When you open up thermos up in the morning, 10 o'clock in the morning, it's still hot. So it's thermally protected from the outside, and what's inside is thermally protected from the outside. Number two, we also have a phase change material that's surrounding all of the battery packs. As you can see here, it's a bit of an eye chart, but we have basically 6 battery packs within here. These are wrapped up with this phase change material. As the batteries are charging or discharging, they'll create heat. What we want to do is remove that heat from that area and bring it to the outside of the case. As number 3 here is heat pipes on the back side of the device, and under here, we're pulling away the heat that's coming from this area through this phase change material out to the outside, so we can actually use convection to cool the system. There are no moving parts. It's all passive. So nothing to break down here. It's all just thermal dynamics that are happening. As you can see right here, we're trying to keep this, we call it the Yotta temperature range. And this is what I just mentioned as well, 20 to 40 degrees C. One of the big things that people always ask about is like, oh, I'm concerned about fire. And anybody that has batteries today is concerned about fire. Fire departments, UL, everybody is concerned about fire, right? So the most important thing is we build in fire protection by design. Number one is low voltage system, as I mentioned. Everything on that roof, LDC conductors are all under the 80 volt NEC touch safe requirement. Boom. So right there, that's huge. LFP, lithium iron phosphate chemistry, the safest today that we know about, and is working very well for us. We've gone through all the UL 9540 and 9540A testing. All the testing revealed nothing. We didn't even see an external flame whatsoever. Probably the most boring 45-minute video I've ever seen in my life, but nonetheless, a good design. The thermal ceramic insulation acts as kind of a fire blanket if there is any kind of thermal runaway inside the device. But what's nice about this particular device is, as I said, it's distributed throughout the roof, and it's distributed under every single module. So that automatically gives us a minimum of 3 feet or more between units. So if there was ever a kind of thermal issue, it would be a single 1 kilowatt hour issue, as opposed to a centralized system that would say you had a 500 kilowatt storage system. If you had thermal runaway with that, you have a 500 kilowatt hour issue to deal with. So nonetheless, quite nice. Pairing with the microinverter, we meet all the NEC rapid shutdown requirements, which is quite nice, and module by module shutdown as well. As far as certifications are concerned, we've passed all, I mentioned the 9540, the 9540A, the UL 1973, 1741 SA and SAB certified, which also equals the Rule 21 compliance, the California JA12, and it's also CEC listed in California today. Let's talk about the smart battery, SolarLEAF smart battery. This right here, this chart is quite nice because it actually just articulates exactly what Yotta Energy is all about today. These are the 3 things that we do, and we do very well. With a smart battery, we're actually able to have what's called time of use. We can actually discharge our batteries at a certain time, at a certain rate for a given time period. We can also work with demand response. So if let's say that the utility wants to reach in and grab power, they need power, they can actually reach in through our gateway, tell the batteries to discharge for a certain time, for a certain rate, and you get paid for that. And also demand charge management. This is actually a 2-part thing right here. This is actually able to look at your system, look at your usage on that particular building, look at how we can discharge throughout the day, and or respond to events happening at your facility and push at that time. So these are the things right here. Time of use. So of course, like for example, in California and many other places as well, but California I think is the biggest offender today, where let's say at 4 p.m., 4 p.m. to 8 p.m., power almost doubles in price. This is a great opportunity for you to be able to charge your battery in the morning and then discharge at a certain time. Let's say at 4 p.m., you just discharge at 200 watts, for 5 hours. Boom. You've actually just tried to reduce your demand on that grid by using the power you've created in the morning. Demand charge management. Again, peak shaving. What we're trying to do here is basically look at the peaks, those high peaks. We see a peak, we can actually respond to that peak and discharge immediately to reduce those demand charges that are coming in for those spikes in power usage. Demand response as well. Here it is, talking about when the local utilities can reach in, you basically sign up with them, they can have access to your system, they can look at your state of charge, and then call on you to provide them power when they need it the most. And then again, of course, during that period of time, they will pay you for that power, and usually at a higher rate than you're buying. Let's talk a little bit about the microinverter and the battery monitoring platform. Any good system today is going to have some type of remote monitoring system. This right here is basically a login for the computer and or mobile app, both Android and iOS, where you're going to be able to have access to your systems. If you're an installer, you'll have access to your fleet. If you're an end user, you'll have access to your site. This is where you log in with a username and password. This is where you're going to be able to see information about your site. We collect information every single 5 minutes for the inverter and for the battery. That information is then pulled together and sent up to the cloud every 15 minutes or 4 times per hour. This right here just to give you a little example of, day by day power production. You have a little bit of history of what's going on these particular sites. Then you can actually get down to the granularity level, and you can actually see module by module performance. You can overstack them on a graph. So lots of information here, and this is really nice for any kind of day-to-day monitoring, but also O&M as well. If there is any issue on the site, you can actually be notified of that issue. The system has to perceive or see that issue for 3 days in a row, has to persist for 3 days. After 3 days, you will get an email that will say, hey, there's an issue on this particular site with this particular product, and these are the 3 things I think you should check. So it will inform you. What we don't want to do is spam you with information. We don't want, when this first issue happens, I don't want to spam you the day that or second that it happens. I want to make sure that it actually persists and continues to happen. But the longest you'll ever go without knowing something's wrong on the site is a 3-day window. Although, like I said, you can log in at any time and see this real time. The other nice thing is downloading reports, we do not truncate anything. All the information is there. So when it's from the system installation date through today, all that information is readily available, all downloadable. You can put that in Excel, CSV files, PNG, PDF, all different kind of file formats, depending on your interest level. In saying that, we're also working on a new product called Yotta Vision. Yotta Vision is going to give us the ability to put all of our battery monitoring and all of the inverter monitoring all in a single location, single place to see everything from solar power, battery power, all located, co-located into the same place. This particular product should be ready for release here sometime, I think, by the middle of the year, but we're very excited, and stay tuned for that. We will have another webinar on this particular product all by itself. So how do we do it? How do we communicate to these devices? And one of the things that we do is have a gateway on site. So this particular gateway is actually, like I mentioned before, it's real-time monitoring of each product. And what it's going out and it's talking to the products and asking questions. What's your state of charge? What's your voltage? What's your temperature? All the different things that are being asked. That's being asked every 5 minutes. And I mentioned before, when you get 5, 10, 15-minute data, that's all together, pushed to the cloud every 15. This device can be either connected to the internet via Wi-Fi, Ethernet, or via cellular dongle. However you want to see it, it can happen very easily. We communicate all of this through Zigbee communication. For those of you that are not familiar with Zigbee communication or communication protocols in general, the industry standard has been Power Line Communications, PLC. This is a fantastic way to communicate. We're basically using the existing power lines to talk to the products on the roof. But in a commercial environment, especially places that have lots of noise on the lines, motors, electric motors, kind of things running around, you may have difficulty communicating to the devices. Here, we're actually using wireless communication. Wi-Fi, which we know and love in our businesses and homes, is what's called a peer-to-point network. The peer being the product, and the point being the router, for example. So your computer talks to the router, phone talks to the router, your Roku box talks to the router, which is great. But Zigbee adds the extra element of what's called a peer-to-peer network. So we're basically trying to increase reliability of the communication protocol. So for example, Ryan is on this call. We were just talking a second ago. If I asked him a question, say, hey, Ryan, what's the weather? He doesn't hear me. I can ask someone else in the room and say, hey, can anybody else out there talk to Ryan? Oh, Bob can. Cool. Hey, Bob, ask Ryan what the weather is. I get my answer either way because of this self-healing mesh network. Let's talk about the DPI. As I mentioned before, DPI comes in 2 different flavors, the 208 volt flavor and the 480 volt. This is all Y configuration today. For the 208 volt, it's a 1728 watt total output inverter, which equals 432 AC watts per channel. As I mentioned, native 3-phase, phase monitored, phase balanced right out of the gate. UL 1741, Rule 21 compliant, and also NEC 690.12 rapid shutdown. Fast forward to the 480, 1800 watts output, 450 watts per channel. Again, native 3-phase, phase monitored, phase balanced. I'll pause here for a few seconds, take a look at this spreadsheet. This right here is the spec sheet on our website. If you get off your phone, scan that QR code. You can download this right from our website to your phone. Okay. So some of the advantages right here, as I mentioned, rapid shutdown compatibility, right? That's huge right now. You don't need an extra thing to shut down the system. It's automatically included in the device. More power generation, right? This because we're looking at independent MPPT. If there is any shading on the roof, one module could be shaded, others may not be. You're still going to produce more power. Challenging installations. We're seeing a lot of rooftop installations, but all kind of broken up now. This is actually very nice to be able to do this. 25-year warranty. That's also quite nice. Panel level monitoring. Like I said before, from an O&M perspective, it doesn't get any better than that. If there's any kind of issue on a roof, boy, you have a visibility to see what's going on anywhere, anytime. And then if you do have to roll a truck, at least you roll the truck with knowledge. You can go out there and actually bring what you need to solve the issue. Okay, let's talk about some of the use cases for these products. Number one, DC clipping, right? We all see this as an issue. We have seen this as an issue in the industry for a long time. The nice thing about this is now you put a battery in between the solar module and the inverter. So any kind of excess power that's being created can go directly into that battery. So we don't have this clipping anymore. We don't have these flat spots any longer. That's nice. That's why we're actually able to use these larger wattage modules in these commercial environments. So we can push out what the inverter can take, but we can actually put the excess power into the battery. So right here is basically saving lots of power and not wasting power. Time of use, okay? This right here is pretty self-explanatory, but I think it's actually a good picture here. Your typical solar curve is you get this nice bell curve. And we do the same thing here. But what we're showing here is we have this time of use. This is your California example. This is your 4 p.m. to 6 p.m. or 7 p.m. or whatever number it is. What we're saying is we're taking this slice of the pie and putting that time and effort, all this, into the storage here. This is actually being saved this morning to be able to be used this afternoon. Again, financial savings. When power goes up and doubles, this is when you're actually able to use this power and discharge this. As I mentioned before, you can discharge at a certain time, at a certain rate for a certain length of time. Those are the 3 variables that you can program. And you can do this multiple times per day. Demand charge management. This is a huge one as well. Okay, especially in these commercial environments, focusing on trying to minimize these demand charges. Demand charges are going to happen. And demand's going to happen. We have new piece of equipment comes on, air conditioning comes on, a tool comes on, whatever is happening. Those demand spikes get charged at a much higher rate. What we're trying to do is 2 different things. I mean, obviously, the easy answer for this is run it at nighttime when power is cheaper. That's just not realistic. So trying to peak shave, trying to cut these peaks down to a manageable level. What we're doing is we're actually monitoring. We're actually got basically a interval data from the buildings. We're actually able to evaluate when the power is used the most. We can discharge the battery automatically during those periods of time, or we also integrate with Energy Tool-based Acumen EMS system. Doing this, we're actually able to clamp on to the building loads using CTs, being able to see real time those demands. And as we see those spikes happen, discharge to meet that demand. It's again to peak shave and manage those charges, demand charges. Real slick. This chart right here just gives you an idea as far as where the higher rates are, and you can see clearly California, Southern Florida, Massachusetts, Connecticut, New York, other areas in the Midwest here. So there's lots of use cases for this particular product throughout the country. Lastly, demand response. Demand response right here talks about being able for the utility to be able to reach in and get power when they want power. This right here gives them the ability. It's basically you're connecting your system. Think of it kind of like a Nest thermostat. Your electric company sends you a message that says, I'll give you $100 if you let me go in there and turn your air conditioning up or down, depending on our needs on the grid. Same thing here. They'll be able to go through the gateway, communicate directly to the SolarLEAFs, and being able to pull power. They'll be able to see state of charge, and they'll be able to pull power when they want it. This is not available in all jurisdictions today, but this is something that's coming. We're seeing a big push for this in the New England states, or that kind of East Coast area. But nonetheless, kind of cool being able to do this. Participating in this is going to give battery owners the grid independence, contribute to the stability, and like I said, earns incentives. A lot of times we're seeing that they're being paid out double what their kilowatt hours are, what they're buying it for. So it's very lucrative to be able to push back and push when you need to. This also applies to NEM 3.0 in California, as I understand it as well. Sometime the August-September timeframe, where we can actually push power back from these batteries because they are a DC coupled system. Let's talk about the design and installation of the system. As I mentioned before, a very, very simple installation, and really only 3 parts. Module into a battery, SolarLEAF, SolarLEAF into the one port of the microinverter, microinverter out to the grid. Couldn't get much more simple. 480 volt systems or 208 volt systems. Simple solar. Some of the design considerations to look at for the SolarLEAF. And typically we all look at, dollars and cents. And one of the things I'm going to point out here is this picture of this as being the water line, if you will, and this being an iceberg. And as we all know, there's more to the iceberg below water than there is above the water. So if we're just looking at equipment costs, dollar for dollar, pound for pound, whatever you want to call it, we look kind of the same. Here's the Yotta solution. Here's your traditional ESS. But if you look at everything else that goes into a traditional ESS system that is not part of a Yotta system, it's very interesting. Like fire suppression is a good example of this. Thermal management, that's all built into our device already, which is included in the equipment cost. Extra transformers, electrical disconnects, because now you're looking at an AC coupled system as opposed to a DC coupled system. Obvious answer here, heavy lifting machinery. You're looking at a huge battery system as opposed to a single 1 kilowatt hour, one person's liftable device. You're obviously going to have to pour a foundation. You're going to have to do separate permitting because it's on the AC side. Independent metering of that begins on the AC side. All the extra engineering design costs. These are all the hidden costs that are below the waterline that are not applicable for the Yotta system. The next couple slides actually show this really same slides, but different. Again, we're starting off kind of a ground zero here, saying this is the standard stuff. This is what the out of the gate stuff. But then you start adding in, oh yeah, permitting, transforming, fire suppression, real estate, land, landscapes, trenching, and you can see that those costs add up quite a bit. And these are kind of some of the forgotten costs with a traditional system that is not applicable on the Yotta system. One question we do get quite a bit. Okay, so it's a commercial product, and so what kind of racking are you compatible with? We have relationships with all of these particular Iron Ridge, Panel Claw, Salega, Unirac, EcoFasten. I think it's the Iron Ridge XR series, including the tilt mount. The Unirac RM10, RM10 Evo. I think Sunmoto as well. I think Sunmoto is on our list as well. If there's a racking company that you deal with that you would like to work with, let us know. Talk to one of your local RSMs. They'll put their name in the hat and see if we can get some kind of compatibility with them. The key piece for us is we want to make sure that it's compatible. The racking is right, the grounding is done properly, and it's all listed. This right here just gives you kind of a schematic of how that all goes together, and this is kind of a better engineering picture. But again, we're really concerned about the inverter going in here, being grounded properly. You can just barely see it from here. Here, there's grounding feet for the SolarLEAF as well. But again, simple solar. Next here, you see the grounding feet here. These grounding feet go in, they get bolted right to panel cloth in this particular example. Same here. The inverter goes into a special tray. This tray right here has PEM nuts already built into the device for the inverter to be screwed down to. This gets screwed into the racking for proper grounding. So let's talk about proposals. And this right here is your typical proposal. This is what you'll typically get. If you call up one of our RSMs or regional sales managers, they will actually go through and look at your case. They will look for things like the address, your power requirements, and kind of come back to you with a proposal. This right here is just an example of one with solar only, and also with the SolarLEAF involved. And what I love about this slide is actually kind of nice, is because it kind of compares the two and returns the return on investment. And it's saying this building right here, you see, was in this kind of SCE territory, and they were able to get an additional $5 million additional savings for adding $91,000. So that's significant. So it's nice to see both sides, the solar only, solar with storage. All of this can be done, like I said, with your local RSM, going through and running it through our financial model and electrical model, being able to pull this back and give this back to you quickly. So the question is, how do you get started? What do you got to do as a customer of Yotta Energy? And I think the key piece is interval data. This right here is gold. If you're able to get an address for a location that you're interested in doing a job, and you can get the interval data, which basically means it's every 15-minute snapshot for a year or more, we can take that information in that spreadsheet form and then put it into our system to be able to crunch the numbers and tell you exactly what you can do with number of solar modules, the number of solar leaves, what the requirements are, and your offset and your return on investment. Secondarily, if you can't get the interval data, which should be available for most commercial buildings today, is utility bills. 12 months or more, just so we can start seeing the pattern. Again, interval data is absolutely the key, because the granularity is every 15 minutes. We're actually able to see spikes and actually program the SolarLEAF to be able to discharge based on history. The third, let's just say you have a new building, a brand new building that doesn't have anything on there yet. So we can actually talk about anticipated storage needs and kind of put together a proposal for you. So it doesn't have to be a building with years and years of history. It can be a brand new building, and we do plenty of them. But nonetheless, this is what you need to get started. Very simple, basically interval data and an address. Get it to one of our RSMs. I have a couple of case studies here. I'm going to pause here for a second as well. I have 3 case studies. This right here is a case study using the ETB Acumen integration. This particular site was just installed in January. It's actually located right here in Austin, Texas. It's actually the headquarters for the retirement system for the state of Texas. And they've actually deployed quite a bit. I think it's 52 kilowatt, 52 kilowatt hour system. The headquarters right on the rooftop, flat rooftop, using panel cloud. I'll pause here a second. You can actually scan this if you want to get the white paper from Energy Toolbase about this particular installation. Okay, moving on. This right here is just another case study. This is actually deals with a CSU DH, Dominguez Hills, in California. This is actually quite interesting, and it talks to our thermal management technology. This right here, you can just barely see it, but you can see that the temperature, the outside temperature, at one point under that module went up to almost 140 degrees Fahrenheit during that peak time. But inside, that green line right here shows you what was happening inside of the SolarLEAF. The thermal management was working hard to make sure that it stayed under that 100 degrees that we like to stick it under. We'd like to keep, like I said, between 70 and 100 degrees F, or 20 and 40 degrees Celsius. That's the magic number. And through the thermal management, we're actually able to do that. And so you can see, even at 140 degrees outside ambient temperature, inside the device was sitting at less than 100 degrees. I'll pause here as well. This will actually give you the case study for this particular site from our website as well. But I also want to show, while we're talking about this, is the performance at normal temperatures and performance at peak temperatures. You can see right here, you can see this right here is your normal solar bell curve here. The green indicates the time of use on this particular site. And this is looking at 2 different times a year too, June and then in September as well. And you can see this right here is the charge. You see the morning, the solar modules were charging that battery and then discharge them in the afternoon. Same thing here, charge, discharge. And you see that normal, so that bell curve from the sun. Okay, let's talk about some of the projects. Monrovia, this is actually on a self-storage location in Monrovia, California. 100 kilowatt system, all using the SolarLEAF battery. The Texas TCDRS, the Texas County District Retirement Headquarters we just talked about, 52 kilowatt hour system. Nice commercial industrial building. A Polaris, this is actually in Ohio. This is one of their distribution centers, a 1.3 megawatt site. Look at it. All of these are actually YouTube videos that are readily available on our YouTube page. So I encourage you to take a look at those if you get a chance. And last but not least, a 34 kilowatt hour site at the Charlotte Police Station. And here's the dynamic duo right here, Chris and Ryan. Again, these are all videos that are listed and are citing on our YouTube page. So please feel free to take a look at that after the presentation. Some of our partners here, these are some of the sites where we currently have installations, the Wawas, Chipotle, AutoZones, Half Price Books is a big one in distribution center in Dallas, the TCDRS we talked about. If you're looking to get the product, currently available at Kranick Solar and also Green Tech Renewables as well throughout the country. Some of the utility relationships we have right now, obviously, we're in Austin, Texas, so we're working very closely with Austin Energy and working with their grid, CPS in San Antonio, and Duke Energy out in North Carolina. These are our big partners right here. Working with them has been joyful, been wonderful. Also have all their installations throughout these other areas throughout the country as well. This doesn't mean you're limited. We're not limited to these areas. We can go anywhere we want, but these are some of the big names that we're working with that have embraced the technology. Okay, we are up to the questions and answer section. We have a few minutes here to run through whatever you guys have got. So,
Chris, we got a bunch of questions today.
Great.
Go ahead and grab a sip of water while you got a second, because we're going to keep you busy here for another couple minutes. Once again, if we don't get to your question, we will be sure to follow up. Somebody from our sales team or engineering staff will reach out to you directly to give you the answer to the question that you asked. But I think we should be able to get through all of these. Chris made it through the webinar in pretty decent time. So you ready, Chris?
Yes, sir.
Joe wants to know, are there structural roof issues with increased weight from the SolarLEAF?
They are not, actually, interestingly enough. So what's nice about it is we like to call ourselves a ballast block replacement. So we're basically removing 2 ballast blocks and we're putting on the SolarLEAF. So basically it's a net zero as far as weight's concerned.
Are there any ambient temperature issues with freezing temperatures or high temperature exposure?
Absolutely. Those are huge concerns, right? And that's exactly what I mentioned before was that is at Yotta Energy, that's our secret sauce is thermal management. We have 3 ways to remove heat and we have a single way to enter heat. So basically, as I mentioned, we have a vacuum packed ceramic boards that surround the battery cells, acting as kind of a thermos, if you will, to protect from protecting heat from getting in from the outside ambient temperatures getting in or cold getting into that device. On the contrast is we have thin film heaters in between the battery packs to raise the temperature in those environments where the temperature may drop below that 70 degrees. We want to make sure that we maintain that warmer temperatures for the longevity of that battery.
What is the module size limit for the LEAF and the microinverter?
It really comes down to, so it's an interesting question. So we say 750 watts STC. So we all know that's standard test conditions, which in a real world will never ever hit. I am more concerned, on the spec sheets you'll see, I'm looking at the voltages and currents of those right there. So 60 volts maximum input with 20 amp maximum input. Those are the two numbers that I'm more concerned about than as opposed to the size, module, or wattage.
I think we addressed this. So when using your system components, are we required to use a proprietary racking system? The answer is no. We have a number of different racking partners that we prefer. The DPI microinverter itself, you can use with a wide variety of racking. When you're talking about using the SolarLEAF in conjunction with the DPI, yes, we have some specific partners that we alluded to. You can find lists of those in the presentation that we'll make available to you after this webinar. But if you have a preferred racking solution, the best way for us to get working with them is to ask the racking supplier if they can come up with a solution. Usually if a racking manufacturer knows there's a demand for a specific type of product, they usually will go ahead and start making it. They don't want to lose out on that market. If you don't see a solution listed now, there's a number of big name companies that we're working on solutions with on the engineering side right now. So I think I pretty much covered that one, Chris, unless you have anything you want to add.
No, I think you nailed it. You nailed it right there.
Will you share this presentation with us? Yes, we will share this presentation with you. We can make it available directly to you, and it will also be posted to YouTube. I think probably by tomorrow, if not end of business today. Chris, any issues with installing on a standing seam roof?
No, absolutely not. So like I mentioned before, there's two ways to mount the SolarLEAF, and actually even the inverter for that matter. You can actually put it into the ballast tray, and or there's actually little leaves, ears, if you will, on both sides of the device that can be mounted to the rack.
Kurt wants to know, could we also push a signal to discharge when we foresee a coincident peak? And what about frequency regulation?
Frequency regulation, I'll start with that one. Frequency regulation is not enacted today. The product is capable of doing it, but not currently, in use. As far as the push, yes, all day long. That could be done through the gateway.
Can you monitor battery levels with the monitoring platform?
Absolutely can. All of that gateway that I showed you is going out and querying the microinverters and the batteries every 5 minutes and putting a profile up to the cloud. That cloud will be available. The information will be available every 15 minutes, although you do not lose the 5, 10, and 15-minute granularity, all of which can be seen from your mobile app and or desktop computer.
So for this fantastic monitoring portal, Chris, is it free to use or is there an additional fee?
It is absolutely 100% free and readily available 24 hours a day.
And is the system production reports considered revenue grade quality?
They are not. Plus or minus 5% is what we advertise. Although saying that, we do have a revenue grade partner in Also Energy. So if that is a requirement for one of your installations, Also Energy integrates perfectly with us through an RS-45 Modbus connection.
How many modules can a single gateway device handle? Will you need more than one gateway depending on the size of the rooftop deployment?
You do. So it really comes down to the number of inverters is really the number. So I guess that would translate to modules as well. We say 80 inverters per, both for battery and for the inverter. So 80 is the number. So I guess 320 modules per gateway. So like, for example, on the Polaris system that we had installed in Ohio, that actually used 9 different gateways because of it's a 1.3 megawatt site. Again, if you had 81, it would work just fine. But we set a number for good reliability. I wouldn't want to put 150 on there and not have the ability for the gateway to speak to all of the products within that 5-minute window.
How much, if any, of the installation is Yotta carrying out? Have you had any difficulties in getting installers schooled up on implementing the SolarLEAF? I'll take the first part of this, Chris, and then you can jump in if you'd like. You may not have been able to tell from the little bit of interaction I've had during this webinar. I'm not particularly technically inclined. I'm more of the sales monkey, which is fine. But we are confident in the ease of the SolarLEAF installation. I've participated in a number of installations just recently in my home state here in North Carolina. The comments from the installation team are like, this is a lot easier than I thought it would be. This is, so you just sit it in here. That being said, we also, for each of the first installation, and even the second if you need it, we will fly someone out at our cost to your site to help participate in the installation and any pre-installation training. That includes the DPI and the SolarLEAF. That's how much we believe in this product, and we want to make sure that you're comfortable with it. So yeah, we do provide, and a lot of times you'll get this guy, Chris, on the job. He's, one of his main functions is to get out and train people in person, but we have an entire domestic base technical support team who's flying around the country. We had somebody in Chile last week, didn't we, Chris? I think
we sure did, right in Santiago.
Yeah, Chile, I think Chile, San Diego, something in the southeast, then up in Connecticut. We're getting a lot of airline miles this year as a company, and it's not even the end of the first quarter. We've got more installations going up now than ever before. We want to make sure, though, that if you need support on one of these installations, make sure you forecast that with us accordingly so we can get you on the schedule and reserve your space. Let's see. We're about wrapped up. We'll make sure we get down to like I said, we'll follow up accordingly. Let's see. We get this question a lot, and we need to address it. I think, Chris, first of all, Anand says, great presentation, Chris. Does the Yotta system provide resiliency?
It does not. No, and that's actually by design. We left the gate trying to work with commercial and industrial buildings to save them money. Understanding that that's actually the biggest cost for them right now, is especially demand charge reduction and time of use. Those are the two key pieces that we left the gate with, and we've continued down that path. Not saying, go ahead, so you go ahead. Good.
Yeah, I think we were both going to say the same thing. I'm not sure exactly what we're allowed to say. As far as resilience is concerned, we'd be crazy not to make it something that we consider on our product roadmap. And I think that's about as far as I can take that statement. Will there be a residential 12240 version? Not in the works at the moment. It's something that we discuss from time to time, but due to the product and some of the limitations it's got with a sloped roof. I guess that's a good question too, Chris, that I see here is, can you use the product on a sloped roof?
You can, but it's definitely designed for a ballasted mount flat roof. It was, like I said, it depends on the racking. I guess it's more of a racking question. It really depends on the slope too. I mean, it's you're looking at a very, very thick battery, almost 4 inches thick. So the module would have to be off that roof quite a bit. I'd be concerned about wind loading and those kind of things. So more of a question for the racking partners.
And just one or two here that I see I can rattle off pretty quick. Will you be making a physically smaller leaf to fit inside the Solega tub? We have a solution that works with Solega. Solega is one of our better racking partners. So we're already compatible with Solega. And what is the turnaround time to get a proposal, assuming all details are given? I got some guys on my team that can turn that thing around same day. It's usually within 1 business day, as long as all the details are given. We had a lot of questions today and a great turnout. I want to thank everyone who came and showed up for this. Chris, if you want to move ahead to the next slide. We do have a winner. I should get a drum roll sound for this. Mr. James Polari. James Polari, you were randomly selected by the marketing team. So you will be, someone will reach out to you and contact you about where we can ship off the Yotta Swag giveaway. Now you can reach any of us, of course, through these different locations. You can get us on our LinkedIn, Twitter, Instagram at yottaenergy.com, and on Facebook, we're at Yotta Energy ATX. You can visit our website, yottaenergy.com. You can email us at support@yottaenergy.com, or for direct sales related questions, that's sales@yottaenergy.com. Chris and I are very busy. Would you like to come and talk to us in person? Let's see, we did Intersolar already. We were just in Boston about a week ago. We'll be at Distributech next week. I've never done that show before. I'm looking forward to that one. So Chris and I will be there along with our CEO and our VP of Finance. So you'll have an executive presence as well as an engineering and sales presence there. And then I'm excited about this. I'll be walking everybody to my home city. I'll be driving over every morning to go to the NABCEP conference. If you've never done the NABCEP conference before, I highly recommend it. It is, I think, the best, pound for pound, the best trade show for industry specialists. A great place to get your continuing CE credits. So I think that about wraps it up, Chris, unless there's a slide here that I'm forgetting about.
No, we're
All
good.
right. Well, successful. I'm glad that we were able to start doing these again. We're going to be doing these once a month. We're going to be bringing some different guests on, having some different topics. If there's a topic you'd like us to see address, please reach out to us. Contact support@yottaenergy.com or sales@yottaenergy.com. Once again, I'm VP of Sales Ryan Davies, and signing off for myself and Chris Barrett. And we look forward to seeing you on the roof or at one of these trade shows coming up. Thank you for showing up.
Thanks, everyone.